Bismillahirrahmanirrahim. Today our lab is implementing the logic of different types of adders and subtractors using carry in, carry out, and at the end we have to make the circuit of arithmetic logic unit on the Verilog HDL. In the previous lab we have covered the adders and subtractors in detail, and we have discussed how adders and subtractors perform their operation using carry in and carry out, and we have already discussed the half adder and full adders. Now I am not going to tell the full details of the adders and subtractors in this lab. Here is the introduction of our lab. In electronics, an adder or summer is a digital circuit that performs the addition of numbers. In modern computers, adders reside in the arithmetic logic unit where other operations are performed. So arithmetic logic unit is a program in which we perform different operations, which includes addition, subtraction, division, modulus, operators which are unary operators, logical operators, equality operators, and operators, and others, so on. After that we have the types of adders. We are already discussed the types of adders, half adder and full adders in detail. So now I'm not going to tell you that. After that we have the following examples. Our first example is Verilog code for the unsigned 8-bit adder. Here is the code is given for the 8-bit adders, in which we have the module name adder, and we have the following input and outputs. After that we have the inputs. We have two 8-bit inputs, which are input A and input B. After that we have the single output, which is sum, which is also 8-bit number, and we have to make the adders circuit. So we have simple assign the sum equals to A plus B, and then our program ends an AND module. This is the simple 8-bit adder of two numbers A and B. After that we have to make the 8-bit unsigned adder with carry input, and our example 2 is 8-bit unsigned adder with carry out. Here we have to make another input, which is carry in example 2. Now I will show you the Verilog circuit of the example. Here you can see that I have written the code for the adders of two numbers A and B with carry input. Here we have the three inputs, 2A and B with 8-bit numbers, and third input is carry input of single bit, and at the end we have a single output sum. Here you can see that the 8-bit carry with carry input, and finally our module end. This is the code for the adder with carry input. After that we have to simulate this. As you can see that I have already compiled that program, and our compilation was successful. After that we have to make the waveform of output and input. Here I am going to insert the nodes. I am giving the input A, which is 12 number. And our input B is 13 number, and our carry input is 1. Now I will simulate this. Compilation starts. Now you can see that our output is generated, and our input A is 12, input B is 13, and our carry input is 1. So at the end finally we have got the output, which is 26. 12 plus 13, 25, and carry input is 1, so our output is 26. This is the simple 8-bit adder with carry input. After that we have our example 3, which is the Verilog code for an 8-bit unsigned adder with carry output, which is simple and will also cover in the example 5. Our example 5 is the 8-bit unsigned adder and subtractor with carry input and carry output, and we have to use the selection input to select between addition and subtraction. So this is our example 5, in which we have to make the circuit for the adder as well as the subtractor with carry input and carry output, and we can use the selection input to select whether we have to perform the addition operation and subtraction operation. Here you can see that I have written the code for the adder and subtractor for the example 5, in which we have the both operation addition and subtraction with carry input and carry output, and I have used the selection lines to select whether we have to perform addition or subtraction. So you can see that here it is the module name adder and subtractor. After that we have our 4 inputs. Input x and y are the two numbers of 8-bit, and input C input, carry input, and input S, which is the selection line. And after that we have the output C out, which is finally C out and subtraction. Here I am using the temporary variable to store the addition. After that we have the always statement on the x, y, and carry input, and here I am using the if statement to perform that operation. And if we have to use the selection statement, here you can see that I have used the if statement. If selection is equals to 0, means that when our selection is 0, then we will obtain the our addition operation, in which temporary variable x plus y plus c input stores, and after that we have to obtain the carry output and sum. So our sum is the first 8 bits of the temporary variable and our last bit, which is the 9th bit, which is the C out. So we have given this statement, and when our selection is 1, then we will perform the subtraction operation, which is answer equals to x minus y, and our program ends and end module. After that we have to compile that program. I have already compiled that program. Now I will generate the output waveforms. Here I am going to insert the nodes. Our input 1 is 13x, and our input y is 10, and our carry input is 0, and our selection is 0, means when selection is 0 we will perform the addition operation. After that, now I am going to simulate this. Now the compilation starts. You can see that our compilation was successful and we have obtained our output. I have performed the addition operation because our select input is 0 and carry input is also 0. So I have given the answer at the 000101111, which is equals to 23. I can already show you in the unsigned decimal. So you can see that 13 plus 10 with carry input 0 is equals to 23. And when we see it in binary variable, we can see that our last bit is 0, which is the carry output bit. So you can see that here our carry output is 0. So in this way we can perform the addition and subtraction in Verilog HDL using these selection lines with carry input and carry output. After that, our final exercise is to construct and implement the logic of a 4-bit arithmetic logic unit. The ALU should contain at least 10 functions given below the table, and we have to make that arithmetic logic unit using the selection inputs. So now finally we have to make the arithmetic logic unit using any 10 operations from these table. So now I'm going to implement the Verilog code for the AL. Here you can see that I have written the code for the arithmetic logic unit of a 4-bit numbers using selection lines. Here we have the module name arithmetic logic unit, and following are the our inputs and outputs. Here you can see that we have the following inputs: integer 1 and integer 2, which are the numbers to add, and we have the following 4 selection lines because we have 10 operations to perform, so we will perform the 4 selection lines. After that we have the output, which is the 4-bit number, and after that we have write the register statement, and after that we have the always statement on the integer 1, integer 2, and from S1 to S4. I have made the ALU using the case statement. Our case is on the S1, S2, S3 and S4, which are basically our selection lines. So when our selection lines are 0, 0, 0, we will perform the reduction or operator on the integer 2 input. And when our selection inputs are 0, 0, 0, 1, then our output 1 is equals to reduction and operation on the integer 2, and similarly so on. Based on the selection inputs we will get the following output. After that finally we have the default statement. When any of these cases do not occur, then our default statement will display, and finally we have our end program. Now we have to simulate this. I have already simulated that program. Now I am going to display the output. Here I am going to insert the nodes. I am going to give the 5 to the input 1, and 4 to the input 2. And our selection, I will give the randomly selection, which is our selection is 0, 1, 0, 0. I have given the selection randomly. After that I have to perform the simulation. So our simulation starts. Now you can see that our compilation was successful, and we have the input 1, 5, input 4, input 2, 4, and we have given the 0, 1, 0, 0 selection lines. And now you can, when you see on the program with the selection input 0, 1, 0, 0, we have the output which is equals to integer 1 divided by integer 2. So basically we will perform the operation 5 divided by 4. So now you know that when we divide the 5 divided by 4, we get the output 1, because this will not see the inputs after the point. So we will get the output 0, 0, 0, 1, which is basically 1. So in this way we can perform the arithmetic logic unit with selection inputs in the Verilog HDL. So that's enough for today lab. Thank you.